And we're back. Welcome back, everyone. I'm Golan Levin, Director of the Art and Code Festival and Professor of Art here at Carnegie Mellon. And it's my distinct pleasure to introduce to you our next speaker, Kelly Heaton, who is a Virginia-based mixed media artist working at the intersection of visual art and electrical engineering. Heaton's sculptures and printed circuit boards depict familiar scenes of nature intersected with blinking, chirping electronics that seem oddly alive. Kelly Heaton also creates artisanal perfume. It's my pleasure to introduce Kelly Heaton.
Hi, everybody. Thank you so much for having me. It's great to be here. I'm going to get started. Well, so what I want to do for the thread of my talk is to help you understand how I make my circuit boards that generate bird song and also look like birds. But before I jump directly to that, I'm going to give you a little background on why I'm doing this in the first place. I came to electronics in my late 20s at the Media Lab, and my background was in fine arts, and I identified with being a painter, but didn't have any experience with electronics. So it was like, whoa, you know, how do I work with electricity? This medium is so cool. I really want to be a part of it. But and looking at electricity, you know, how do you do that, right? You can't really see it. So, you know, what is the form of it? So coming in initially, I had to collaborate with people because I didn't know how to do it myself. So I started by asking myself, how could I give electricity form? So instead of having, you know, a monitor, like, could I make systems of pixels that were, you know, three-dimensional and reconfigurable? And then could I have, for example, an artist's palette that instead of mixing paint, mixes colors of light? And I worked with an engineer named Stephen Gray on this, and that was great. But still, as an artist, I felt like I'm not really touching the electricity. I'm not getting into what it really is. So that led me to looking at how can I learn electronics. And so, you know, you've probably, many of you, seen these familiar diagrams of schematics and circuit boards, and they meant nothing to me, right? Because I didn't speak electrical engineering initially. And I couldn't help but to see, when I would look at those diagrams, I would see things like this is an acupuncture diagram. And I'd be like, wow, you know, it seems kind of like it's the same thing. So that led me to looking at other types of electronic devices, such as the Furby. He's looking kind of sad, sorry. That I, you know, for example, would remove the brain and put it in another location. And I turned bunches of Furbies into a large sculpture that mirrors your body in Furby. So that was cool. And as I was doing it, I spent a lot of time like a naturalist looking into the circuitry of the Furby and analyzing it as though it were an animal, because in my mind it seemed to be. And I couldn't get around this idea that, you know, the electricity that flows through computers is like the electricity that flows through bodies, and it brings computers to life, it brings animals, it brings me to life. Like, that's fascinating to me. This is a diagram that I made later on, actually, when I was working with perfume, where I indicated the chakras in bodies with all this energy flowing around. And to me, that things like that look like circuits. So anyway, so that's where I came from. But as I began to deepen my practice of electrical engineering and get a little bit better at making things, I wanted to be able to make my own devices, not just modify Furbies or Elmos or whatever, but make my own devices that were lifelike. So that started me on a path. It was very long, 20 plus years of exploring how you make lifelike circuits. And I first had my first successes with insects. So this is leading to birds, right? But chirping insects are simpler. And then from there, I increased the complexity and was able to get some sounds that sound, kind of like bird song. So I'm going to show you how I do that at my electronics bench, and then moving on to my screen printing studio, which is where I add the visual element of the circuit boards. But on my way to my electronics bench, I want to do a demonstration for you of my sound circuits. Initially, I was just going to demonstrate them one by one, but then I thought, what the heck, let's just plug them all in. And so that's what I did. So I apologize in advance as I'm walking and carrying my laptop if it's a little bit not such great video, but here we go. So over here, first I'm going to turn on my insects, and then I will turn on the birds, and I'm going to walk you through the soundscape. Now, as I'm walking around this side, these are my perfume bottles. Yes, I make perfume, and I'm sorry that I can't really get into that today. It's not enough time for that. But to say that I experience electricity and the flow of electricity through circuits is vibration. And that same vibration is also something that we can smell, a different experience of it. So I love how all together they sound like a jungle. All right, so I'm going to bring you over to my electronics bench now. Turn off these guys. It's kind of sad to turn them off, but anyway, it's a little distracting. All right, so how do I do that? Obviously, I have audio amplifier circuits, but that's not really where the exciting stuff is happening. The exciting stuff is happening in my creation of vibration. And I do that by making analog electronic oscillators. So I built a really, and of course I just dropped the power supply, but I built a really simple one to show you what an oscillator is on a very basic level. And then I'm going to move on and show you how that builds complexity. So here we've got some lights blinking back and forth. They're oscillating, right? And if I change the resistance in the circuit, it changes the blink pattern, right? So it's pretty simple. And that's how I do it. I make a bunch of oscillators and I couple them together in different ways. And based on those couplings, I can create patterns. So now I'm going to plug in another really simple circuit, and it's one that you actually just heard, one of many. But this is a cricket. Oops, upside down cricket. So the pattern of the light that you see there is showing you the oscillation that's happening in the circuit using the same components that I used in the simple blinking light before. The only difference here is that I have the audio out, and I also have a second oscillator that's controlling the timbre of the chirp. So instead of just a boring kind of fire alarm beep, beep, a sine wave sound, I'm adding vibration to the quality of the sound, and that's what makes it sound more of that nice chirp tone. There's one other thing I wanted to point out here, since this is a conference about homemade, but oops, the light's bad here. Let's see. So that yellow circuit board here and my piezo disc, which I have in a little styrofoam egg cup because it works really well to amplify the sound. That is something that I built by myself, not because I'm crazy about making my own speakers, but because Radio Shack used to make these wonderful piezoelectric buzzers, and then they stopped. And suddenly my insects didn't chirp like I wanted them to. So I made my own. And by the way, I put the schematics on Hackaday so that you can make one too, if you have a need to make crickets and don't have the right piezoelectric device. Okay, so from insects, so simple oscillators, moving on to insects. From there, I started breadboarding all different kinds of circuits. And it's not like I just did this, right? It took me a really long time to do this. So don't be intimidated. It's just really about failing better and being really stubborn. But anyway, so these circuits combine, in this case, usually it's like 4 or 5 oscillators with a transformer output that is from a circuit that's been around forever called the doorbell canary. And I put together these different circuits to make bird-like patterns. So one, here's another one, and another one. I'll hold this up so you can see it. My super dirty breadboard, wires going everywhere. So, I'll go back to this one for a second because I wanted to just show you that one of the cool things about using a breadboard like this, actually, this is actually demonstrating why I wanted to move on and make circuit boards, because the wires get loose and it's easy to break stuff. But if I just plug and unplug the wires in different patterns, I can create different songs. So I love that. And I thought, well, all right, I got to get away from these being, oh, and by the way, sorry, before I move on, I wanted to just point out this little transparent guy right here, which you saw in the large bird sculpture. I don't know if you caught that, but the circuits that I just demonstrated for you are what I pack up inside of these little transparent birds. So yeah, this is fun. It's great, but they break so easily. It's difficult to reproduce. It's often very difficult for me to even extract a schematic from it, just because the complexity of the wires and so forth, it's really easy to make a mistake. So I decided it would behoove me to make it as simple as possible. So I had elements then that I could bricolage together to be able to make my birds and my insects faster. So that led me to this project, Deepfake Birdsong, where I broke out 5 different oscillators, and then the sound circuitry is all inside of the bird. And I did that, again, just really for my own purposes, but also hopefully that it makes it easier for others to understand. So this guy, same idea. There are adjustable resistors in here inside of the circuit that will change the quality of the bird song. All right, so from there, getting that circuit figured out, I was able to come up with a schematic and put it into a circuit board. So this is the same circuit that you just saw. In some sort of weird mode. The bird's mad at me. In some sort of like really angry bird mode. get the idea. So by putting it into a circuit board format, it then enabled me to establish my schematics, have something that's reproducible, and then continue to build on that complexity. So, oh, I did skip something that I wanted to show you real quickly before I move on to my screen printing. This piece here, which is, this was like back in 2018, and actually prior to that, all the way back, I don't know, I would say for the last like 10 years, really, this was the modality that I was working in, where I would get a bird-like circuit that worked, and then I would build it into paper. And I love that, don't get me wrong, I'll probably continue to do that as well. But moving on to circuit boards, and I'm gonna move on into my screen printing studio, so apologies if my video is bad here as I'm walking, but circuit boards are beautiful. And I really, I don't know why it took me so long to get the idea. I guess because I was just so focused on trying to learn the electronics in the first place. But once I moved on to the idea of designing circuit boards, it was like, oh my gosh, the traces, they have such wonderful geometric patterns. And I love how they reference, like, you know, ornamental design from so many different cultures and chinoiserie elements, and it's just beautiful, the possibilities aesthetically with circuit traces. So, but making circuit boards, so yes, you can have them made for you by a manufacturer, but there are limitations on how large they can make them. There's limitations on color, and it is fun to work, you know, within those limitations to figure out, like taking from, this is just the copper layer of that board I just showed you, the Angry Bird. It's not always angry, but was tonight. And figuring out, okay, so going from the copper layer, knowing the solder mask and the silkscreen colors that are available to me, how can I make, you know, a representational image? And that's a great challenge, and I love to do that as well. But it's also fun to figure out what other types of fine art practice could I bring to circuit boards to make them even more beautiful and have even richer visual elements. So this is a set of, oops, it's falling apart, of transparencies that I produce on a film printer that I have here in my studio. And using these layers, I can add colors to, well, in this case, a print. So the same art that can be used to generate a circuit board can also be used to generate a print. And that opens up all kinds of really cool possibilities, because the more complexity I can add with color, for example, this is not a functional print per se, but you can see that the birds are caged inside of a circuit board, right? And that circuit board actually generates parrot songs, but no circuit manufacturer is going to give you all of this color, and plus it's on paper, and so there's like a lot of aesthetic richness that I really love. And so from there, what I'm working on now is to figure out how to push the circuit element even further, both aesthetically. These are, you know, traces in a, I'll show you up close. I'll explain to you in a minute why the holes are there, but you can see this is it's canvas on a panel that where I've laser cut the holes out, and this is why, if you see there, I'm adding circuit elements back in. So here's the little cricket that you saw before. I can put my circuits back into these holes. And then there's this whole world of possibility open to me, because at that point, you know, I can paint and I can screen print and I can incorporate my electronics into it. So that's the direction I'm taking my practice now, and I'm really excited about it. So I want to show you one other thing over here, because, you know, if you're going to make circuit boards, why not make them really big, right? So I'll show you this guy. So yeah, this is the work that this is where I am now. So this is, by the way, I made this all in my studio with a combination of laser cutting, with screen printing, with foiling. For example, so this print here that I recently made for Creative Capital has foil that I ironed onto. They use this to make t-shirts. So I've just been looking for ways to, to find materials and media and methods from various different sources that I can then pull together to achieve this like lush, beautiful circuit board effect, but also have the functional electronics. I do dream of making giant circuit boards that are actually circuit boards, so etching them, and I've been talking to some manufacturers about that, but yeah, as you can imagine, like you want to do what? So anyway, but I'll do it. I'll get there. Yeah, so I think that's pretty much the tour that I wanted to give you here. Don't know where I am on time. Well, close. So I'm going to walk back to where my power supply is and take some questions from you guys. Yep, there's my timer.
Thank you, Kelly.
You are welcome.
Hey, got lots of fun questions in the chat here over on Discord. That was an excellent tour, and it was lovely seeing your work, both from the really sketchy and raw stuff to the really large and impressive stuff that you're devising entirely new technologies and techniques for creating.
Hey.
Do you ever try to imitate specific birds, or do you sort of make a circuit and then figure out what it sounds like, or what's your relationship to these birds? Are these birds that are sort of in your backyard in Virginia, and you're sort of like, this is your sonic world, you're trying to recreate these specific birds? What species are you using there, Kelly?
Well, the easy answer is a mockingbird, right? Because they make any sound. So I do have a special place in my heart for mockingbirds. The truth is that to date, my skills as an electrical engineer haven't been good enough to say, there's a sound, I know exactly how to reproduce it. But to be fair to myself, I also think it's actually a really hard problem when you're coming at it from analog electronics, because many of the effects that I get, the interactions that I get between my oscillators, are totally surprising and nothing I could have ever expected, because I'm not sitting down and, being extremely deterministic about, like, I don't do the math. I mean, yes, I draw schematics and so forth, but I don't sit down and analyze, like, okay, this capacitor and blah, blah. I don't put my stuff into Spice. So it's definitely experimentation, but you can be sure if I hit on something that sounds familiar, like my Pretty Bird circuit, which I didn't demonstrate to you, but you can see on my Vimeo page, sounds kind of like a Carolina Wren. It sort of goes Pretty Bird. Yeah.
I'm not sure if you're familiar with Garnet Hertz's work in cockroach robots, but he has made robots that are controlled by live cockroaches. And a question from the chat is, have you ever worked on or wanted to make cyborg systems with insects that involve actual living things, kind of collaborating with other kind of electronic components?
The answer is absolutely not. There's a reason for that. I was accepted to veterinary school and I was working on my PhD in immunology. And the reason I dropped out, and probably I should have always known from the beginning that I was going to be an artist, but I did not like the laboratory experimentation with animals at all. So I like wilderness, and I like to get along with my animal friends. I'm not saying that all of it's hurting them, but yeah, I'm an animal lover.
One person asked, they were like, wait, you make perfume? And You
It's
just
kind of hard to put that.
you just casually dropping bombs like, oh, I dropped out of veterinary school and oh, I make perfumes. But maybe could you talk about the relationship of your perfume practice to the rest of your making practices, or like, is there a relationship? Like what, like how does that relate?
Well, you and I talked about this recently. I guess I'm really an energy artist. So I'm super interested in the flow of energy through all things. I'm also a tarot card reader and I like magic. And I find that when you look at it in terms of energy and you think about perfume and the experience of perfume and how you construct it as energy, as frequency, same as the frequency of the color fields in a painting, same as the energy and the frequencies that happen in a sound circuit. Ultimately, it's all about the energy and the vibration. And I think that's really the crux of where I focus my creativity.
I think this is excellent for now. We're at basically at time. So I want to thank you so much, Kelly, for giving us this incredible view onto your creative practice and your studio. It's lovely. This term energy artist is something where people are mulling over. It's just a delight to also visit your space and to get this kind of intimate tour. Thank you so much. I hope you get to enjoy the rest of the festival now that
Yeah,
you've
thank
taken
you
us
so much for having me. Thank you.